Okay, let's start our today class. Today class is a very important class, and today class we will derive an equation which is called thin length equation, and we will do some process for source reduction को जैसे कि हमने पिछले कहा था कि हमारे साथ जो कि सोर्स होते हैं, पहले हमारे साथ एलईडी है जो कि लाइट को एमिट करते, इन दफ़ा हम कोन इसको क्या करते एमिट करते। इस कोन का जो साइज होते है ये हमारे साथ ऑप्टिकल फाइबर के कोन से साइज से बड़ी होती है, तो इसका हम साइज को रिड्यूस करके इसी तरह स्मॉल सी साइज वाली कोन बना रहे थे ताकि वो क्या हो जाए, इसमें आसानी से पास हो जाए। और इट इज़ बिहेव लाइक अ कपलर, क्योंकि हमने कहा कि वायरलेस में हमारे साथ एंटेना होते जो कि कपलिंग का काम करते, ठीक है, कपलर का। और फर्स्ट क्लास में हमने ये कहा था कि इन द केस ऑफ ऑप्टिकल फाइबर कम्युनिकेशन हमारे साथ जो कि हमारे साथ कपलर क्या होती है, ऐसी एक सोर्स होनी चाहिए कि हमारे साथ जो सोर्स कौन है इसको इसका साइज इस तरह रिड्यूस करे ताकि वो ऑप्टिकल फाइबर से पास हो जाए। तो ये हमारे साथ कपलर होगा। सो इस कपलर के बारे में एंड में बात करेंगे। सो लेट्स स्टार्ट द मैग्निफिकेशन। और पिछली क्लास में हमने रूल्स के बारे में पढ़ा था कि फॉर एग्जांपल लेंस से जब लाइट पास होती है तो कौन सी रूल्स वो फॉलो करते, और रे किस डायरेक्शन से हो तो किस डायरेक्शन से वो पास होंगी। Consider this is the lens and this is the object, and one ray is passed from its center, and you know that the center passing ray is undeviated ray, ये हमारे साथ डिविएट नहीं होती। और इसका जो सेकंड रे है वो हमारे साथ के पैरेलल टू द एक्स एक्स पैरेलल टू द central axis of lens, and you know that when the ray parallel to the axis of the lens fall on the surface of the lens after transmission, it will pass from the point, and this point is called focal point, and this point is called focal point. ये जो image and this is its image. This ray is intersect the undeviated ray at that point, and here the tip of the object will be found, and here its tail will be found. So it make inverted image. But remember that this image size will be greater than this. For example, here we have drawn, but this is not some good. This is its center. So let's suppose this is the object. One ray will pass from the center, which is undeviated. The second ray will pass parallel to the surface, and after it will, and after transmission, it will cross the, and here we will form the image, and you know that this image size is greater than this. सो कहने का मतलब जस्ट ये था कि दिस इमेज साइज विल बी greater than this, but here I have not make it greater. So what does uh, this O D naught F D I show in this figure? So O represent the height of object and I represent the height of image. The D naught represent the distance of the object from the lens, and di represent the distance of image from the lens, and small f represent the focal length. And you know all these, and here discussion portion that O is the height of the object, I is the height of image, d naught is the distance between object and lens, and di is the distance between the image and lens, and f is the focal length. And you know that there are two rays uh, which we use to design the um, image of object. The first ray is central ray, which is undeviated, and the second ray is parallel to the axis of spherical lens, which will pass from the focal point after transmission. जब आपके साथ ये पैरेलल रेज पड़ जाए लेंस पे, तो आफ्टर ट्रांसमिशन ये पास होगा फोकल लेंथ से, फोकल पॉइंट से. ये हमने पिछली क्लास में डिस्कस किया था. And the intersection of the ray will produce the tip of the object, which is inverted. So it is the property of the spherical lens that maximum images formed by the object is inverted, real, and sometimes equal in size, sometimes greater in size. So you know that you can study that at what point these depend that when the image will be smaller than object, when the image will be equal than object, and when the image will be greater than object. But here we does not discuss this as that when we will get how which type of image when you place the object anywhere. So this is our figure number 1, and figure we will use the figure number 1 and will derive the equation of the lens and will define the magnification. So uh, let's repeat our figure. This is the central line, and this is the object which is placed in the front of the lens, and it is image. And how this form, we use just two rays. There are many rays coming from this object from each point, and they'll intersect from here in each point. But for sake of convenience, we use just two rays. So let's suppose the one ray is its center ray, which is undeviated, and the second ray is parallel to the axis of the and the second ray is parallel to the axis and pass after transmission. uh, it will pass from the point which is called focal point. and an intersection, the tip will be found, and similarly the inverted image will be found. Here d naught represents the distance of the object, f represents the focal length, di represents the distance of image from the lens. So you know that here in the figure there are two triangles. One is one contain alpha. Here it contain alpha and here it contain alpha. These two are the and there are two other triangle which contain beta. This is angle beta and this is angle beta. We will use these two triangle to derive our length formula. So let's move toward our derivation. So before to derive the equation, so we will study what is the magnification. So magnification is the ratio of the size of image to the size of the object. We can also say that it is the ratio of the height of image to the height of the object, and this is called magnification, and magnification is represented by m. So m is equal to I divided by O, where I represent the height of image and O represent the height of the object. So in figure 1, there are many triangles. So consider the triangle which contain alpha. There are two triangles which contain alpha. The left side triangle, if we draw the triangle which contain alpha, so you know that it was this. This is the object, this is the image, and this is the central ray which is undeviated, and its ray make two triangles which contain alpha. This triangle is left triangle and this triangle is the right triangle, and in this right triangle there is perpendicular O and there is a base d naught. O is the object of the height is perpendicular and d naught is the base of the triangle. And you know that tangent alpha is equal to perpendicular by base. So tangent alpha is equal to perpendicular between O divided by d naught. This is our equation number 2. Yes, this is our equation number 1. Image height divided by object height. So second equation is tangent alpha is equal to O divided by d naught. Now consider the right side right angle triangle. So now consider the right side right angle triangle. This is the left side right angle triangle. This is the right side angle right angle triangle. By right angle triangle, we mean that it contains 90 degrees, and this is 90 degrees. So this is the right angle triangle. So in this triangle, the eye is the perpendicular and di is the image. Di is the base, and we know that tangent alpha is this is perpendicular, this is base, and this is hypotenuse. So you know that what is tangent alpha? It will be perpendicular by base, perpendicular by base. tangent alpha is equal to I divided by di. So this is the equation number 3. If we compare, you know that this alpha and this alpha will be same. This is about the trigonometry, that opposite angle are same. So it means tangent alpha here O divided by d naught, and the tangent alpha I divided by di. This equation, this value will be same. Whatever this is, mean that as the size of this triangle is larger than this. This is smaller triangle, this is larger triangle, but the ratio must be same. So if we compare the equation 2 with equation 3, now we want to compare the equation number 2 to equation number 3. So in equation number 2 there was I divided by in equation number 3 there was I divided by di, and equation number 2 there was O divided by d naught. You can write also that tangent alpha is equal to tangent alpha. So in equation number 3 the tangent alpha is I divided by di, and equation number 2 the tangent alpha is O divided by d naught. If we rearrange the equation, by rearranging mean when we shift O here and di here, so we will get the equation number 4. The I divided by O is equal to di divided by d naught. This is our equation number 4. And you know that what is I by O? This is the formula of magnification. So we can write here that this is the magnification, which is equal to di by d naught. This is our equation number 5. So it means that this is the definition of magnification also, that it is the ratio of the distance of image. It is the ratio of distance of image from the lens to the distance of object from the lens, di by d. This is the second formula of the magnification, that it is the ratio of the height of image to the object, and it is also the ratio of the distance of image from the lens to the distance of the object from the lens. Now consider other two triangles which is made by the secant ray. So you know that the secant ray pass parallel to the axis, and after transmission it will pass from the point F. And this make angle beta here and beta here. But if we consider the figure number 1, so you know that the distance from lens to the image is di, and the distance from the lens to the focal point is f. Distance here, this distance is f, and this distance is di. So what is this distance? I mean, what is this distance? So you know that if we divide, if we minus this distance f from the di, this is di and this is f, so di minus f, we will get di minus f. So this distance is di minus f. Understand this equation? इसका
Yes,
समझ आ
sir.
गया? ये आपके साथ सारा डी आई और ये आपके साथ एफ है, तो इस पोर्शन से अगर हम इस पोर्शन को माइनस करते हैं साथ ये पोर्शन, सो डी आई माइनस डी एफ. So now consider this triangle. This contain beta and this contain beta. So if we consider our second triangle which contain beta, so this is our diagram. Here the triangle contain beta and triangle contain beta. So what is the perpendicular here? So you know that this is the perpendicular and this is equal to this. That means this is O. So in the left triangle, the perpendicular is O and the base is the length of focal length F. So tangent beta is O divided by F, and this is our equation number 6. Now consider the second triangle. So in second triangle, the perpendicular is I and the base is di minus f. So if we consider the second triangle, so the tangent beta will be equal to image height divided by di minus f. This is our equation number 7. If we compare the equation number 6 with equation number 7 as previous, the tangent beta is equal to tangent beta. But in 7, tangent beta is I divided by di minus f, and in the equation number 6, this is the O divided by f. So if we rearrange, we will shape O here. So I by O, and we will shape di minus f here. So di minus f divided by f. This is our equation number 9. This is our equation number 9. And you know that what is I by O? So it is the magnification. So the magnification is di minus f divided by f. This is equation number 10. And you know that the magnification is also equal to di by d naught, which we derived some moment ago. Di by d naught. So if we compare this equation, this was equation number 10 and this was the equation number 5. Okay. So if now we compare the equation number 5 with equation number 10, so m is equal to m, write m is equal to m, magnification is equal to magnification. So what is the m? Di by d naught. What is the m? Di minus f divided by f. Di by d naught is equal to di minus f divided by f. This is our new equation. So if we divide its both side on f, this on f, so di by d naught, so we will get di divided by f minus f divided by f. If we divide di by f and also this f by f, इसको इस पे डिवाइड कर, इसको इधर माइनस है, माइनस f को इस पे डिवाइड, so you will get di by f minus f divided by f. Minus f divided by से आ जाएगा 1. So the equation will be di by d naught is equal to di by f minus 1. if we divide the both side of equation 11 by di, so what is mean by division? We will write di and denominator. We will write di and denominator, and we will write the di and denominator. So it means that we have divided the both side of equation 11 by di. So a di will be cancelled toward this, and this di will be cancelled to this, and we will get 1 minus di. So we will get 1 over d naught is equal to 1 over d, 1 over f minus 1 over di. So we will get this equation that 1 over d naught is equal to 1 over f minus 1 over di. If we rearrange the equation, so 1 over f is equal to, इसको यहाँ से अगर इधर शिफ्ट कर दीजिए तो इधर माइनस, इधर it become plus. So 1 over f is equal to 1 over d naught plus 1 over di. This equation 12 is called thin length equation, and it is very important equation. It shows the relation between the focal length and the object distance and image distance. So if you know any two, so you will get three. Third one, for example, if you know the distance of the image and distance of the object, so you can find the focal length of spherical lens. And if you know the focal length and the distance of the object, so you can get the distance of the image. And similarly, so this is our equation number 10. If you multiply the both side of equation number 12 with d naught, so what you will get? If you multiply d naught here, so it will become d naught, and when you multiply d naught here, so it becomes d naught, and when you multiply d naught here, so it will become d naught. Now this become 1. So d naught divided by f is equal to 1 and d naught by di. And when we rearrange this, d naught divided by di is equal to 1 minus d naught divided by f. Can you derive this equation from this equation?
सर सिंपल है, यहाँ पर ये डी नॉट डिवाइड बाई एफ है, ये पॉजिटिव में है, उधर चला जाएगा तो ये नेगेटिव में हो जाएगा.
Yes. Okay. So this is very simple. So d naught divided by di is equal to 1 minus d naught divided by f. And what is d naught divided by di? It is the reciprocal of m, because m was the di by d naught, di by d naught. So if we say that d naught divided by di, so it will be the reciprocal of m. So 1 over m, this becomes 1 over m is equal to 1 minus d naught divided by f. And if we take reciprocal of m, so we will get m is equal to 1 divided by d naught divided by f minus 1. M is equal to 1 over d naught divided by f minus 1. So this is the another equation of the m. This is the another equation of magnification. that magnification is equal to 1 over d naught divided by f minus 1. So we have derived many equations which show the m, magnification of the lens. So let's consider an example on this problem, that if the magnification is 1, so find the di and d naught. अगर आपके साथ magnification 1 है तो आप क्या find करें, di और d naught क्या करें, find करें. So you know that what is m? M is equal to di by d naught, and m is 1. So di divided by d naught is equal to 1. So it means that di is equal to d naught. The value of di and d naught will be same if the magnification is 1. And you know the thin lens equation, that 1 over f is equal to 1 over di plus 1 over d naught. 1 over f is equal to 1 over di plus 1 over d naught. So if we write 1 time di, 1 over di, and plus 1 over d naught की जगह भी di लिख सकते हैं क्योंकि di is equal to d naught. So it will become 2 divided by di. 1 over di, 1 over di is equal to 2 divided by d. And if we write d naught here, 1 over di की जगह d naught plus 1 over d naught, so we will get 2 divided by d naught. We will get 1 over f. If we multiply, cross multiply, so we will get 2f is equal to di. And here if we multiply, so we will get 2f is equal to d naught. So it means that d naught is equal to di is equal to 2f. If we multiply here, so we will get 2f is equal to d naught, and 2f is equal to d naught. So we can say that d naught is equal to di, which is equal to 2f. So अगर हमें f given हो, if we know the f of the lens, so we can calculate the di and d naught. So if the f is 1, focal length is 1, so then d naught will be 2 centimeter. If f is 1 centimeter, so d naught will be 2 centimeter, and di will be 2 centimeter. If the f is 2 centimeters, then d naught and di will be 4 centimeter. समझ आ गया कि it depends on f, क्योंकि इक्वेशन में उस टाइम में f नहीं दिया था, but here we get the f. So if you know the f, so you will get the equation. So if it means that d naught and di depends on f, the f is 1 centimeter, then di will be 1 centimeter. Sorry, 2 centimeter. So not 1 centimeter, this is 2 centimeter. And if the f is 2 centimeter, then di and d naught will be 2 multiplied by 2, it becomes 4 centimeter. So it depends on f. This is our simple numericals. Now we will move that spherical lens as a channel coupler. And you know that what is coupler? Coupler is the last minor block of our transmitter, that it will couple the transmitted data to the channel. In the case of wireless communication, this is antenna, which in the case of in the case of wireless communication, it is an antenna. An antenna will feed the transmitted data to the wireless channel, which is atmosphere. But in the case of optical fiber communication, the channel is fiber. So, and uh, the source that radiate energy is LED or LD. So how we will couple the radiation of LED or LD laser diode to the optical fiber. So the source that is LED radiate energy in the form of core, and this is called source radiation core. And you know that this, for example, this is our LED, so it will radiate the energy in such a manner so that make a core. This shape is called core. This is called source radiation core. And the size of the source radiation cone is very large as compared to the focal optical fiber. So if we compare the size of optical fiber, you know that the diameter of optical fiber is 1.5 millimeter. It is very small. So the optical fiber size is very small. So this is the light source and this is the source radiation core. But if you couple here, this is the source, it will radiate energy. This is optical fiber. This is 1.5 millimeter. So it will, some rays will be untrapped. These are untrapped rays. And these are trapped by the fiber. It means that we lost some energy here and some energy here. So if we reduce the size of this cone, so we will not lose any energy. So if we feed the source radiation cone to the optical fiber, some energy will be lost as the fiber will not trap all the rays of the core and there will be untrapped rays. For example, this is source, this is optical fiber, these are untrapped rays and these are trapped rays. So untrapped rays में हमारे साथ क्या होता है? We will lose some energy. So the fiber can trap all the rays of fiber when the size of the cone is equal to the fiber acceptance core. If the size of the cone is reduced to the fiber acceptance core, this is the fiber acceptance core and this is the optical fiber. So no ray will be untrapped and all rays will be trapped by fiber and we will not lose any energy. And this is called fiber acceptance core. What is fiber acceptance core? The radiation core which when we feed this into the optical fiber, so all the rays of the cone is trapped by the fiber. Then this this cone is called fiber acceptance core. So how we will reduce the size of the cone? They are trapped by the optical fiber. So in order to feed all the ray of the source radiation cone efficiently to the fiber, we need to reduce the size of this core. The size of the source radiation cone is reduced with the help of spherical lens. In other words, we use the spherical lens as channel coupler in the fiber optics communication. चूँकि साइज ऑफ द कोर हमारे साथ क्या था, बड़ा था, इसको रिडक्शन के लिए हम क्या यूज़ कर सकते हैं? स्पेरिकल लेंस. और जब हम इसका साइज को कम करें तो इसका मतलब ये है कि इट इज़ कपलर, it is behave like coupler. So the source is, so how we will reduce? So let's suppose source is located on the left side of the focal point. ये हमारे साथ focal point है, ये हमारे साथ spherical lens है. This is the focal point of the spherical lens and this is our LED or LED. It is the source of radiation. So consider the source is left side of the focal point. In previous class you studied that when the light source is in the left side of the focal point, so they will radiate the light in such a manner. So we consider here three rays. The one is central ray, and the one is this ray, and the other is this ray. So the central ray is undeviated, and this ray will be uh, intersect the central ray, and this ray will be intersect the central ray after transmission, but they will intersect the central ray at some distance apart at the right side of the focal point. हमारे पास फोकल पॉइंट है, इसका राइट साइड में क्या कहते हैं, इसको इंटरसेक्ट करते हैं और यहाँ से क्या करते हैं, it and this is its image, this is the source and this is the image, and now this image is behave like source and they will radiate the energy, they will radiate the energy, and this is its core. So the size of the cone is reduced. We will derive mathematically that this angle is smaller than this angle. So the remaining two rays intersect the central ray on the right side of the focal length. So here this is the D naught, this is the image, and you know that the distance of the image is D naught and the distance of the image is Di in this figure. So consider triangle on the left side, perpendicular of this triangle is P and the base is D naught. Similarly, consider the triangle at the right side and its perpendicular is P and, so if we consider this triangle, right side triangle here, or right side triangle, and if we consider this is our right side triangle, this is our left side triangle. So in this triangle there is a 90 degree, in this triangle this is a 90 degree, so this is a right angle triangle. So here the perpendicular is P, here the perpendicular is P. This is also alpha, this is alpha, this is alpha, but this is alpha naught, this is alpha I, alpha object and alpha image, and this is, if this is alpha, so this is alpha I. So now we will derive that this alpha I is less than alpha naught, and if the alpha I is less than alpha naught, it means that the size of the cone is reduced. So this is alpha naught and this is alpha I. So the tangent alpha naught is equal to P divided by Di, and similarly the tangent alpha I will be equal to P divided by Di. समझ आ रही है इसकी?
Yes, sir.
ठीक है कि tangent alpha naught is equal to perpendicular by base and tangent alpha is equal to perpendicular by base. So this is our equation A and this is our equation B. The tangent alpha naught is equal to P divided by Di and tangent alpha I is equal to P divided by Di. So if we divide this equation by A, so we will divide tangent alpha I by tangent alpha naught. You know that when we divide here, so tangent alpha I divided by tangent alpha naught. So what is tangent alpha I? P by di divided by P by d naught. And you know that P by di multiplied by d naught by P, and they will become cancelled. So we know that tangent alpha I is equal to tangent alpha I divided by tangent alpha is equal to d naught divided by di. And what is d naught by di? It is the inverse of image 1 over magnification. 1 over magnification. So I'm trying to use a scientific calculator, but don't know that how I use Google. But you do know that now it use the radian or not. You see here that if we take the tangent of 0, 2, that will give approximately 0, 2. If we take the tangent of 0.3, we will get approximately 0.3. What is this mean? So if the angle is in radian, if the angle is in radian, ये बात याद रखिए, if the angle is in radian और ये एंगल बहुत स्मॉल हो, फॉर एग्जांपल अभी मैंने 0.2 0.3 इस तरह स्मॉल एंगल कंसिडर किया, सो इन दिस केस अगर आप टेंजेंट इसका अगर टेंजेंट ले या ना ले तकरीबन आपको सेम वैल्यू दे, फॉर एग्जांपल टेंजेंट ऑफ 0.2 आपको आपने देखा अभी 0.2 के बराबर था और टेंजेंट 0.3 के बराबर था, तो यू कैन we can say that the tangent alpha I is equal to alpha I and tangent alpha naught is equal to alpha naught when the angles are in radian and they are very small. अगर एंगल हमारे साथ रेडियन में हो और स्मॉलर हो तो हमारे साथ फिर अगर इसका हम टेंजेंट ले या ना ले तो सेम वैल्यू आएगा, तो अल्फा आई एंड अल्फा नाट, टेंजेंट अल्फा आई की जगह में अल्फा आई लिख सकता हूँ और टेंजेंट अल्फा नाट की जगह में अल्फा नाट लिख सकता हूँ. सो हमारे साथ जो इक्वेशन ये हो जाएगा वो इस तरह हो जाएगा कि 1 over m is equal to alpha I divided by alpha naught. Here alpha I is divided by alpha naught is equal to 1 over m. So 1 over m is equal to alpha I divided by alpha naught. If we take the reciprocal, so m is equal to alpha naught divided by alpha I. And what is alpha I? When we shift alpha I here, so we will get alpha naught divided by m. This is a very good equation. Alpha I is equal to alpha naught divided by m. And you know that m is the magnification, and the magnification is always greater than 1. Magnification मतलब 1 से greater. So when we divide the alpha naught by some value greater than 1, so it means that its value will be smaller than alpha I is equal to alpha naught divided by m. So अगर alpha naught को हम m से greater value पे divide करते तो इससे smaller value लेगा. So it means that alpha I is smaller than alpha naught. اور اگر الفا آئی الفا ناٹ سے اسمالر ہے تو اس کا مطلب یہ ہے کہ اس جو یہ ریڈیٹ کرتا تھا اس کا سائز اور ابھی جو امیج ریڈیٹ کرتا ہے اس کا سائز کے اسمالر ہے. کیسے؟ یہ ہمارے ساتھ ایک سورس تھا، یہ دیکھیے this is alpha naught and this is alpha I, and you know that if this is alpha I, so this is must be alpha I. So یہ الفا آئی ہم نے فائنڈ کیا کہ کس سے اسمالر ہے، الفا ناٹ سے. کتنی اسمالر ہے؟ اس کا میگنیفیکیشن پہ اگر ڈیوائڈ کیا جائے اور میگنیفیکیشن 1 سے گریٹر ہوتی ہے، سو اگر اس کی ویلیو سے کم ہے جس کا مطلب ہے کہ یہ الفا آئی جو ہے یہ والی کون اس کا سائز اس کون سے کے اسمالر ہے. یہ جو کون ہے اور یہ جو کون ہے اس کا سائز اسمالر ہے، کیونکہ ادھر ہمارے ساتھ انکل الفا ناٹ ہے اور ادھر ہمارے ساتھ الفا آئی ہے، اور الفا آئی جو ہے الفا ناٹ سے اسمالر ہے. اس کا مطلب یہ ہوا کہ یہ جو سورس تھا اس کا جو ریڈیشن کون تھا اس کا سائز ہم نے ادھر کیا کرنا کم کر دیا. ہاؤ what is the factor that we reduce the size? The factor is m. تو اس کا ہم نے m ٹائم کم کر دیا. کتنا؟ m ٹائم. So as the m is greater than 1, it shows that alpha I is less than alpha naught. And it means that the size of the cone image is less than the object image. Object cone. جو object cone تھا اور ایک image کا cone ہے تو یہ ہمارے ساتھ کہ اس کا size کم ہو گیا. And you see that if this is the image object and it produces angle alpha naught. So this is alpha I and this is also alpha I. So this size, the cone size is reduced and they will be feed easily to the optical fiber. And you may know the principle, this is called hygiene principle, that for example آپ یہ بھی پوچھ سکتے تھے کہ یہ تو آبجیکٹ تھا اور اس کا بھی امیج آ گیا، ٹھیک ہے. سو یہ جو ریڈیشن کرتا ہے یہ ریڈیشن اور اس ریڈیشن میں کچھ فرق ہونی چاہیے کیونکہ یہ ادھر ریڈیٹ کرتے ہیں اور ابھی ادھر ریڈیٹ کرتے ہیں، ٹھیک ہے. سو ایک سائنٹسٹ تھا، اس نے کہا، اس کا نام ہے ہائیجین، اس نے یہ کہا تھا، ہائیگن نے جو بھی مجھے پتہ نہیں لیکن اس طرح کچھ رولز اس نے بتائے تھے، اس کا نام مجھے بھی ایگزیکٹ یاد نہیں ہے کہ کیا تھا، اس کو ہم کچھ پرنسپل بولتے تھے. یہ پرنسپل یہ ہے کہ اے آپ کے ساتھ کیا ایک پوائنٹ ہے، دس از اے پوائنٹ وچ ریڈیٹ دا انرجی، ٹھیک ہے. اگر سنیں دے سڑی سنو وہ ہائیگن. سو ہائیگن نے یہ کہا تھا کہ یہ ہمارے ساتھ دس از اے سورس وچ ریڈیٹ دا انرجی، سو ہمارے ساتھ ریڈیٹ کرتے، ٹھیک ہے. سو ہمارے ساتھ سیکنڈری پورشن پہ ایک ایسی پوائنٹ ہو سکتی ہے کہ یہ پوائنٹ آپ کے ساتھ سیم انرجی ریڈیٹ کرے گا، اس کو کہتے ہیں ویو فرنٹ. پر یہ ہمارے ساتھ سورس ہے، اس کا ویو فرنٹ کچھ اس طرح ہے، ٹھیک ہے. سو ہمارے ساتھ ادھر ایک پوائنٹ ہو سکتی ہے ادھر، ٹھیک ہے. دس از کال سیکنڈری، دس از کال پرائمری، دس از کال سیکنڈری، اور یہ سیم انداز میں ریڈیٹ کرے گا انرجی، ٹھیک ہے. سو دس از پرائمری پوائنٹ، دس از سیکنڈری پوائنٹ، اس کا جو ریڈیشن ہے اس کا ریڈیشن سیم ہے. تو اس طرح یہ بھی ایک پوائنٹ ہے، یہ پوائنٹ، اور ساتھ یہ بھی ایک پوائنٹ ہے. تو اس کا ریڈیشن اور اس کا ریڈیشن کیا ہوگا؟ سیم ہوگا، لیکن اس کا سائز گریٹر ہوگا اور اس کا سائز کیا ہوگا؟ اسمال ہوگا. سو اسپیریکل لینس کو ہم نے اس طرح یوز کیا کہ اس نے اس کا سائز کم کر دیا اور اس کی وجہ سے اب اس کا فیڈنگ ٹو آپٹیکل فائبر از ایزیلی ہم کیا کر سکتے ہیں، آپٹیکل فائبر میں اس کو فیڈ کر سکتے. سو اس کا بھی فنکشن کیا ہوگا؟ ایز کپلر. کیونکہ اگر آپ کو میں فرسٹ لیکچر تھوڑا اوپن کر دوں تو اس میں یہ تھا یہ دیکھیں ہم نے کہا کہ کیریئر سورس کو ہمارے ساتھ کیریئر سورس ہمارے ساتھ ایل ای ڈی ہے جو کہ کیا کرتے کپلر ہونے چاہیے. یہ ایک ٹرانسمیٹر اینٹینا تھا اور ادھر ہم نے کہا کہ یہ ہمارے ساتھ سورس ریڈیشن ہے, یہ جو انرجی ہے یہ ریڈیٹ کرتے, ٹھیک ہے. آئیے ہمارے ساتھ کے آپٹیکل فائبر اس کا 12.5 مائکرو میٹر اس کا کہ ڈائیمیٹر. سو اس کا سائز اس سے بہت بڑی ہے, تو اس کا ہم کیا کریں گے سائز کم کر دیں گے. جو سو کم کر دیتے ہیں اس ڈیوائس کا نام جو اس کا سائز کو کم کرے اس کا نام ہوگا کپلر, ٹھیک ہے. ادھر ہم کپلر پڑھ رہے تھے کہ اٹ فیڈ دا سگنل ٹو انفارمیشن چینل. In wireless communication, it is the transmitted antenna which radiate the energy into wireless channel. But in the case of optical fiber, ہمارے ساتھ ایل ای ڈی ہوتے ہیں, ایل ڈی جو کہ ریڈیشن کرتے, ادھر ہمارے ساتھ آپٹیکل فائبر ہوتے ہیں جو اس کا سائز اس سے بڑی ہوتی ہے. اس کے لیے بھی کچھ ہونی چاہیے تاکہ اس کے لیے فیڈ ہو جائے. سو اس کو ہم نے کہا تھا کہ اس کا نام ہوگا سورس ریڈکشن, سورس کون اور ریڈکشن. سو ادھر ہم نے ریڈیوس کیا ان دا, اس کو ہم نے ریڈیوس کیا کس کی مدد سے, in the help of spherical lens. So the spherical lens can be used as coupler. So اگر آپ سے کوئی یوں پوچھے کہ کپلر اسپیریکل لینس کو ایز اے کپلر کیسے یوز کرتے, تو آپ کیا کریں گے اس طرح اس کا ایکویشن ڈیراو کر کے اس کو بتا دیں گے اس طرح یوز کر کے. کوئی آپ سے پوچھے کہ how we will reduce the size of the code, so we will reduce the size of the code through this mathematics. So this is all about today lecture. In coming lecture we will do some numerical problem using our 10 lens equation and this equation. So in coming class we will do some numerical equation on these formulas which we derived today. Thank you.